Right. Good morning, everyone. Good morning. Hello, I'm Carlos da Silva, and I'm joined today by Goutham Pacha Ravi. Both of us work at Red Hat, and we currently work at the storage team, specifically in the OpenStack Manila component. And we would like to share with you today some nice stuff that we've been working on enhancing high availability and how high availability for CephFS NFS unlocks a great promise with OpenStack Manila. So yeah, without further ado, let's get started. This is our agenda for today. So first, how we are integrating Manila with CephFS today, and then what's new in that integration and with CephFS NFS Ganesha clustering. A quick demonstration and what are next plans for the next couple of cycles. So first, a very quick intro on OpenStack Manila. So OpenStack Manila is the shared file systems as a service for OpenStack, and that's a way that you can provide NFS, CIFS, CephFS, and other shares from other protocols in your cloud. So Manila has a whole bunch of nice features, like you can pretty much control ACLs or access rules. There are multi-tenancy. It's like secure, elastic. You can shrink or grow your shared file systems, and yeah, a whole bunch of features. We won't cover a lot of that today because we'll focus on a specific part with the CephFS NFS driver. So first, how did we do the integration with native CephFS before? So the CephFS shares, we would call them, they are actually subvolumes that are served as Manila shares. And so we have like volumes in the Ceph storage, and then we create subvolumes and serve them as shares. And there are two ways. One of them is you can use the CephFS native protocol, and the other them would be CephFS over NFS. This is the way we have the native CephFS protocol. So how does it work at the end? Well, we'll have like a storage provider network that sends the Ceph public network to the user VMs, and then the user VMs will have access to the shares, and they will be able to mount and write data to the shares. And the CephFS with the native driver works very well for environments where we have trusted end users and in a private cloud. Now covering how do we do the CephFS via standalone NFS. So the driver uses an NFS Ganesha gateway to provide NFS protocol access to the CephFS subvolumes. So it's all through NFS Ganesha. And how do we do that with like networking and connectivity? Well, there will be two network interface cards or NICs connected to the VMs, and one of them will connect them to the project router, and the second one to the storage NFS network. And then that way, users will be able to mount the shares. So Ganesha will take care of the exports manipulation. NFS Ganesha will take care of the exports manipulation in that case. And it will use dbus, the dbus API to talk. And there's a premise that it would be nice, or the best case scenario is in case you are using it, dbus API and the Manila share service should be in the same place. Otherwise, like you would need to do that through SSH, and there would be like some drawbacks on performance and performance and some other stuff. Won't get to that too, but yeah, that's a nice thing to have in mind. And yeah, it will have, as I said, it will be served in an NFS gateway, and we will use NFS Ganesha. So this is what it would look like. So this, we are abstracting here in this picture like the OpenStack. So these users we are mentioning here, they are OpenStack users, and they are mounting shares on VMs or shared file systems. And NFS, we have in this example like 3 instances of NFS Ganesha, and this is active, passive, standby. So pacemaker will be controlling with a VIP. So this is a pacemaker controlled VIP, and it will pretty much check on like the availability and the uptime of the NFS Ganesha instances, and that's pretty much the thing with like electing another one in case something goes wrong. And yeah, this has like some performance drawbacks, and it would be nice if we could have this working with active, and that's what we have been working on for the past couple of releases. And there's there's a lot of updates to that, which Goutham will cover right now.
Thanks, Carlos. So yeah, so the limitations are evident, right? It's the aspect that we don't have a way to recover very fast from some sort of failures, and we've tried hard to build this solution in deployments where we do work within the NFS timeouts and so on. So clients have some resilience as well built in, but it's still not the best case scenario. And it's not just the aspect of availability; it's also the aspect of scale, in the sense that this severely limits how many clients can connect to your cluster without seeing a huge performance drop. So what's next? Well, the Ceph community and the OpenStack community, we've been working together for a couple of years now on trying to make this situation better. And the innovation happened first within the Ceph community to make NFS a first-party protocol within a Ceph cluster. So today you could deploy NFS as a Ceph service, pretty much like any other Ceph daemon. So it is abstracted behind a concept called Ceph NFS. That's a new service, and so you can deploy this service in an active manner directly on your Ceph cluster nodes, and you can front end this service with an ingress service. So you can make it look a lot like the old solution by saying that there is just one NFS endpoint, but there could be a cluster of NFS services behind this endpoint. And so the end users would connect to that ingress through the ingress to the and they get scheduled on a NFS server that's on the back end. So this gives us scale, and this also allows us to distribute the availability aspect of things. So if one of your services goes down, there is a way to recover through the other services that are always up. And there are some subtle aspects that we got out of this as well. So we solved the deployment inflexibility issue as well that Carlos was mentioning. So at this point, we don't really need to co-locate OpenStack services with the NFS service because we no longer use the dbus API. We started using a Ceph Manager API. So there's now a built-in integration within Ceph where you can tell Ceph, hey, I would like NFS exports. Create me a subvolume, throw in some NFS exports, give me access to X number of IP addresses or Kerberos even, and Ceph will take care of all of that as an API. So it makes the interaction from OpenStack so much more easier. And what else? I think we also had this aspect where OpenStack was doing a lot to manage the export configuration. So NFS Ganesha is I mean, it's also a storied project with a lot of history. So it needs a lot of config upfront. And so we would manage in Manila an export counter. And we would try to make it thread safe and all that stuff by making sure, like, if you have a burst of services, requests that are coming to say, create me N number of exports, we'd actually struggle a little bit because we're counting up how many exports we can actually divvy up and configure properly without running into each other. So all of that is taken away from OpenStack now. So this is happening within Ceph, and there's some amount of coordination that Ceph has built in, just like any other Ceph service, as far as the concurrency control goes. And so the sizing of the NFS service, again, is something that an OpenStack administrator doesn't need to worry about anymore. They could now go with a bill saying, hey, here, I expect X number of users, and the Ceph person or the person that's managing the Ceph cluster is now looking at the sizing of the Ceph node pretty much the same as any other Ceph service. So these are some of the advantages we gained over this approach. So you can actually react to load dynamically because you're watching your Ceph cluster and so on. So it allows the OpenStack service and like OpenStack Manila to treat Ceph NFS as a black box and pretty much treat it like any other storage driver that's there in OpenStack Manila. And so in this case, in this example out here, we have a 3-node Ceph cluster. And to deploy it is actually pretty simple. It's that command out there. It says Ceph NFS cluster create. And we're creating a cluster called CephFS, very confusing. But we're putting that on 3 nodes, storage 1, storage 2, storage 3 in our case. And we're front-ending it with an ingress. We're telling it what IP address to use as a virtual IP. And it's an interesting ingress mode out there. We're saying use HA proxy protocol. This is, again, something that we worked with the Ceph community for. And the idea here is the ingress is what is seeing the traffic from the clients. We want to make sure the NFS service is seeing the traffic as well, so that it can apply ACLs. And so if it doesn't see the client addresses, it doesn't know who's making the request. It's always going to think that the ingress service is what's making the request. So that's why the ingress mode is important. And this was an improvement that was required for the NFS Ganesha stack as well. So today, because of HA proxy protocol, you can have A ingress and N number of services, and we still can apply client level access controls. And besides, that's how the spec looks on the Ceph side. If you're used to Ceph Adam, that might look familiar to you. It might show you the count and the play and some other metadata over there. So let me step into a demo mode over here. And I apologize, we used ASCII Nama to record this demo, but if this is not legible on the screen, that's the URL to get to it. And you have access to these slides as well in case you want to click through them later. So let me see. So let's start playing this. So we're on a machine where we're trying to deploy OpenStack and a Ceph cluster. So this is me logging into Ceph Adam, and we're trying to list all of the orchestrator known services. So there is a Ceph NFS that's deployed over here, as I showed you in the previous command, and then we have a Manila service as well. And I'm going to show you the Manila service configuration, what that looks like. It's pretty simple if you're familiar with how services are configured and how backends are configured. That's the Ceph driver, the protocol helper type. It's going to front end this with NFS. And interestingly, we also have CephFS in this. So we're exposing both CephFS and NFS. But like we were discussing previously, these are fundamentally different. NFS is for a more traditional use case, more secure in some sense in a multi-tenant cloud-led OpenStack. So here's some more configuration. We have some client nodes where we're trying to go access some of this some of the shares. And let's look at these. So we had we have some secrets mounted on these on the Manila node. The secret involves like where is this Ceph cluster? What is the etc ceph.conf? So those are the Manila services. In this case, we also have a NetApp. Sorry, I didn't show you the configuration out there for the NetApp, but that's a Manila capability that you can have any number of backends. We called a share type, big box type, try to provision some things on the NetApp, but let's use the default share type to create a NFS share. And this is going to go to our Ceph backend. And that's the NFS share that's coming up, and it is available already. And that's how the export location looks. So typically, an end user would go mount this on their client machine. But before we do that, we got to provide them ACLs. And that's the access create command. So we'll give them access, read-write access. Let's go into a node and start mounting the share, right? And we can start typing, touching some files, writing some data, and so on. So as an end user, all of this looks really simple, but what it takes to put together is all of the operations that went in behind, right? The integration was quite painful. and today, we're actually very happy that we are able to provide some pretty simple operator experiences as well as the user experience built on top of this. And we're also able to make it look like big box storage. which is pretty cool for Ceph users in the room, I suppose. And as with any RWX storage, you can actually go mount it in multiple places. You can access your data from multiple places. And let's think that was pretty much the demo saying this stuff works. It is ready for prime time, and we would be excited to see more and more users use this stuff and tell us how things are working in your cloud. I mean, for a long time, we've heard from operators how difficult it is to manage active passive service like NFS front-ending CephFS. A lot of people do want to go back to CephFS just because it gives them better performance, and putting NFS in front of CephFS is a bad idea where you have like a cloud that requires that performance. But we're hoping this is a better solution than we had in the past few releases of OpenStack and for the past few releases of Ceph. So we're now in the past cycle we were working on migrating existing use cases of Ceph NFS to this clustered NFS, and we weren't able to do this 100% non-disruptively. There are challenges here because you are actually moving NFS servers, and it's not just the export configuration that's getting translated, it's also the traffic. And you want to make sure that this traffic switches over within NFS timeouts and so on. And there's still some work being done within NFS and Ceph communities. But if you were to do this today, there is some things that OpenStack Manila can do for you that makes things easier. What are those things? Well, if you're trying to decommission your old cluster, you can tell Manila where the new cluster is. Sorry, you can tell Manila where the new cluster is through configuration. And Manila knows that there's a difference between an old and a new cluster, so it will start representing export locations in two sections. It tells you that there is a non-preferred export path, so that your new clients will start using the preferred export paths from your new NFS cluster. And so that's a UX change that we were able to make with Manila. And then what you can do as an operator is you can have a decommissioning period. You could tell your users that, hey, it's going to go away in 15 days or maybe 3 months, right? So as long as you would like and you can afford in your cloud, and as long as the users can migrate over. And this migration can happen a little slowly. We would really like the decommissioning period to be short, so you don't really run into issues where you might have data living. The data is always living in one place, but I meant like 2 different kinds of access, right? Some of it is working in a different way. Maybe the performance in the old NFS service was completely different from the new cluster that you have. You don't want to give your users that different user experience and confusing user experience. So we recommend the decommissioning period to still be on the lower side. And I'm going to quickly jump to what else we're doing. We're trying to work with the Ceph and the NFS Ganesha communities to come up with these next few things. The last one is purely OpenStack and the KVM communities, which is Word.io-FS, still in the works. So if you've been in the room with us in the past, I think we're finally getting there with epoxy. So some of those patches should merge in epoxy, and you should have some support for Word.io-FS. And then a lot of people that want to use CephFS native still have the same kind of secure experience with using Word.io-FS directly with native CephFS rather than trying to use NFS in front of CephFS. So that's the idea. And for any Samba users in the room, we are going to start working on Samba integration as well, because IBM and Ceph have started prioritizing Samba support for Ceph. So it's going to start previewing in Manila in probably the next release or so. So I'll stop now. And if you have any questions for us, we'd be happy to take them. Yes. Yeah. So right now, all of CephFS. Oh, sorry. Let me repeat the question. So you asked if what multi-tenant NFS would look like, and on a little more of a detail of that. So it's a long story. So technically, right now, if you were to deploy a single backend, so you're literally telling all of your tenants on the OpenStack side that there is one NFS ingress. All of you guys are using this ingress. So it could be untrusted OpenStack tenants. They're all sharing an NFS service at the back end. And the only way you can mitigate that is by deploying multiple NFS services. And that's what multi-tenant NFS really means. And the NFS Ganesha community wants to improve that experience. Try to namespace and try to probably add different ingress for different tenants and so on. Manila has some primitives for it. They don't directly translate with the NFS Ganesha land. So that's the part we are trying to do. We'll try to publish some stuff how this can be done.
I'm asking because I run a primarily bare metal cloud, so we don't have security group, and we have untrusted tenants using NFS Ganesha right now. And we've got some kind of hacky workarounds to kind of make this work.
Yeah, we'd love to talk to you about that. So yes, untrusted tenants, and I'm pretty sure you as an operator has to take some care today. We'd love to see what that experience looks like because we want to make that better. We're not sure this would scale as well as a commodity storage, like commercial storage. Sorry, but it's got to start because there is some interest. Multi-tenant NFS with.
Thank you.
You mentioned in the slides that this NFS is versus CephFS is possibly, I mean, it's a different use case, but it's also possibly more secure. Can you just address a little bit what you meant by more secure comment?
Yeah. So the question was, what is the security posture difference between native CephFS and NFS? So as the Ceph cluster goes, you have the Ceph public network. So if you're trying to use native CephFS, your clients need to have access to that Ceph public network. And there are other parts of infrastructure on that Ceph public network. So if your clients have access to the Ceph public network, they could be, they have direct access to the MDS daemons, the OSDs, and so they have a way to get to these. So if you have untrusted clients in your not in your environment, not that these are malicious users, but they could be doing something that would impact your infrastructure, which would impact everybody else using the cloud. And so we've seen a lot of pushback, or rather disinterest in people trying to expose CephFS to traditional multi-tenant OpenStack clouds.
So a firewall doesn't work.
So you can. So the way we suggest the use of CephFS, native CephFS in these multi-tenant deployments is you're trying to prevent a bunch of tenants to use it. You probably are going to provide access to trusted tenants. And so the way you do that is with probably neutron RBAC rules around the public network and so on.
Every tenant or every user is going to get their own access key. So how is that a security risk versus NFS?
So you need to call this, I'm sorry. But yeah, thank you. Please do contact the speakers today or however means you want to contact them, but we do need to call this because we have starting.
Thank you so much. And
What reason error to have?